Hello everyone. As we covered in our previous video, encapsulation is a core principle of object-oriented programming. Encapsulation is bundling or enclosing of data and the methods which operate on that data into the single unit called class. That is called as an encapsulation. So encapsulation helps to restrict the direct access to some of the objects component by allowing a access level restrictions on variables, methods or class. And it helps mainly towards the data integrity. For example, let's say these are the fields and methods which are encapsulated under bank account class unit. These fields are marked as private. So we'll understand about the private and public in next slides. So because these fields are marked as private, they can be accessed only via the functions of this bank account class unit. So it is a controlled access. So let's understand about the different types of encapsulation, the compile time and runtime encapsulation and different access levels in detail in next slides. There are four types of encapsulation. First is data encapsulation. It prevents the direct access to the variables of the class and only allow control access using the getters or setters method. Getters means get method to get the variable and setters is set method for updating the variable. So if you see this bank account class, the balance is private here and it can be updated using the set method of the bank account class unit and get balance method of the bank account class unit, right? It is not accessed outside the bank account class. So this is called as a data encapsulation or the variable encapsulation. Next is procedural encapsulation. It hides the internal processing logic, not allowing direct access to methods or functions which are handling that logic. So the procedural encapsulation is for a methods or the functions of the class. So if you see here, these are the two private methods of this class ATM, and it can be accessed only via the another class, another method of the class ATM, withdraw cash, right? It is not accessible outside the ATM class. So this is a procedural encapsulation. Next is class encapsulation. So it prevents the unauthorized object creation or modification, useful when we want to manage the object creation internally for specific class. For example, here you can see the constructor of database class itself is private. So nobody can create the object of database class from outside this database class. So this is useful when we want to maintain the object creation in that class itself, like in a singleton pattern. Right? So this is a encapsulation at a class level. Module or package encapsulation. So hide the specific classes or functions from being accessed outside their module or their package. For example, here the bank account class is public, deposit method of that bank account class is public, and it is under the package bank. Now, if we access this bank package in another package, we can only access the methods or class which are public declared in this package. So this is a module or package level encapsulation. Access specifiers. So in previous slides, we discussed about the private, public variables, but what exactly it is, right? So access specifier, so the access level helps to control the visibility or accessibility of the class, methods and variables, right? Different languages have a different way to apply access restriction. Not all access restriction types are supported by all languages. So here we are not talking about the syntax, we are talking about the access level, right? And different languages supports the different types of access levels. Not all supports all types of restriction types, right? So we'll start with the private restriction type or the private access level and go till public access level. So it is the order of more restrictive to less restrictive. Let's understand the private. So it restricts the access to the class members like variables, methods or constructor to within the defining class only, right? So the members to which class they belong, that class only can access the private variables, methods or constructors. Then the default access level. So it is applicable only when no access specifier is specified explicitly, right? And behavior depends on to the language. So when we don't specify any access specifier in a code, then the default access specifier comes into the picture. Like in the language C++, the class will be private by default. the scope will be like that can be accessed within the class itself. Class member will be private by default, and those variables or methods can be accessed within the class only. In a Java, the class will be private by default, but the access will be at a package level. So other classes can also access that private class. So similar to the class member, right? So we can see different language have different behavior for the default access level. Then next is internal access level, which allows the class method or variable to be accessible only within the same assembly, which is .dll or executable file. Not all languages have this support. So this is more specific to C# language. Other languages can also support it by in a different ways, but exact support won't be there, right? And as we mentioned initially, not all languages will support all type of restriction levels or restriction types. Then protected, so allows the class method or variable to be accessible within the defining class, and also allows the access in a derived or a subclass, even if they are in a different package or assembly. Like if there is a bank account class, and if we create a child class of that bank account class, let's savings account, then all the variables of that bank account class will be accessible in a savings account class, the variables which are declared as a protected. If there is no such child parent relationship, then it falls back to the this first one, like the access will be within the defining class only, right? Then the public, no restriction, it can be accessed from anywhere. So these are the different access levels we discussed. Let's understand the compile time and runtime encapsulation. Compile time encapsulation, the access control is enforced by compiler during compilation, and which helps to prevent the unauthorized access before the program runs, right? And it is enforced using a like syntax, like private, public, protected in a syntax in a code. So compile time, basically when you write the code, at that time only you will come to know. In advanced editor it will show the red sign, or you will get the error when you build the code, right? That it is not allowed. For example, here the balance is a private variable. When we directly try to set it or access it, we'll get the compile time error that it is a private variable, right? So it is not supported by all languages. Like the compilation step might not be there in all languages, like Python, which is a dynamic typing language. So this type of encapsulation, the compile time encapsulation, is not supported in a Python or similar languages, right? The next is runtime encapsulation. So access control is enforced during the execution, right? And it is enforced using some validation logic. So it is in our hand, right? We'll understand that. Let's say here the balance is a private variable. It is, if you see the set method here, we are having some validation logic. If the balance is greater than 0, then only allow, otherwise throw the exception. So during runtime, if we try to put some invalid value here, we'll get the error. So we are trying to maintain the data integrity with some our custom validation logic. So we are enforcing the runtime encapsulation, right? In some of the languages like Python, when we discuss, the compile time encapsulation is not possible, but the runtime encapsulation is possible using techniques like name mangling, property annotation, etc. Right? So during runtime, it checks that part. So for example, you can see in a Python, the private variable is declared like that. The method which can access those private variables are declared like that, right? So during the execution or the runtime, when the actual program runs, we will get the error if we try to directly access the private variables, or the private the method basically set some wrong invalid logic. Here also we added some custom logic also on top of uh, the the provided encapsulation by the Python. So this is a runtime encapsulation. Then bypassing the encapsulation. Encapsulation can be bypassed in some of the languages, like using reflection in a Java. So bypassing encapsulation is not recommended practice. For example, how that can be bypassed, if you see in a Java, this is a private variable balance, but using a reflection technique, the encapsulation can be disabled, and the private property or private variable can be modified, right? But this is not a recommended practice. One thing we need to understand, that encapsulation principle is more with the design part of it, right? Not just security. So what object oriented programming encapsulation principle tells us, that as a developer, we need to have this encapsulation principle enforced, so that because of any code issues or some logic issues, or mistakenly, unintentionally, we don't write any logic which will uh, basically make our data invalid or make our logic exposed, right? So encapsulation is more around using the right design principle, right? And that is what object oriented programming is trying to enforce on us, or trying to tell that we need to follow this best practice, right? It is not just for security, where we are just applying a different access levels for like making data security, right? It's more around design part also. So hope you understood about the encapsulation in detail, the different types of encapsulation, the compile time and runtime encapsulation, different access levels, and how we can bypass the encapsulation, which is not recommended, and how to consider encapsulation as a design principle. So if you like the video, please share and subscribe. Thank you.